So the phrase first do no harm is often associated with the Hippocratic Oath. This is an oath taken by doctors that contains various ethical standards that they should abide by. The purpose? To ensure that they provide high-quality care to their patients. In fact, it takes doctors anywhere from 7 to 9 years to even be finished with all of their schooling. I sat down with a respected physician and asked him, what's the deal? What is all involved in becoming a doctor? And here's more or less what he said. So you need to major in math and science when you're in college. You take the MCATs, hopefully you pass them, get into medical school. Okay, great. And then you take step 1 of this USMLE exam. You do rotations, there's step 2. And then it was what? Even more stuff. You have an internship, more exams, perhaps doing residency, then doing a fellowship. And I was just wow, that is a lot of work just to become a doctor. Why do you think we ask so much of them? Isn't it because we trust them with our lives and the lives of our friends and family? As software developers, we have the power to connect people with the information they need the most. They use our applications in order to do their jobs, handle their finances, and stay in touch with friends and family. However, unlike doctors, we weren't required to take some sort of oath or pledge when we became software developers. But I still feel that we can learn a lot from the principles behind that phrase, first do no harm. One question people ask me a lot is, Annyce, how do I become an Android developer? And I hope that today I can answer not only this question, but this one as well. How can I become a great Android developer? What does it take to really push myself to that next level? I'm sure you've probably heard somewhat cliche that success is like an iceberg. People normally only see the end result, but it actually takes a lot of hard work, dedication, and perseverance to truly be successful at anything. So we're going to look at various things that we can do to put in that type of effort to be great Android developers. And it's going to be 3 different areas we're going to cover. And the first is related to how we approach study. Now, once someone becomes a doctor, they don't just learned it all, spent 9 years, I'm over it now. No, they keep learning. They take various courses on new medical techniques, they read medical journals, they attend conferences, all in an effort to stay up to date in the medical profession. And we too have many resources that we can use to make sure that we keep our skills relevant in the Android industry. So the first one that we're going to talk about is related to newsletters. I'm a big fan of newsletters. These are 3 of my favorite ones. So Kotlin Weekly, Android Weekly, and Android Dev Digest. Okay, so we got a fan here. What I love about newsletters is that I get this in my inbox. I can take my time going through the various articles. And although I'm a huge fan of Twitter, so follow me now if you're not, I like the fact that the articles and newsletters are vetted. So I know that someone has already taken the time to make sure it has valuable content, and then this way I can maximize my efforts when it comes to learning new things. Next, we'll take a look at podcasts. So there are a ton of podcasts, to be honest, but these are the ones that I listen to the most consistently. What I super love about podcasts is that you get to hear from real-world developers. So they're out there tackling the same challenges that you're trying to tackle. And what's especially nice about Android developers backstage is that they interview the engineers who are working on the frameworks and the software that we use to power Android. So it's great to hear from them the why behind how they decided to design or implement something. This moves me to the third item, and that's online courses. What's great about these in particular is that you can tend to go at your own pace. So sometimes when you're maybe like in a workshop or in a public setting, you have to try to keep up with others or perhaps maybe slow down to work with the whole crowd. But you don't have to worry about that if you sign up to take an online course. The next thing is that they tend to cover all aspects of Android development. So you can learn about layout files all the way to publishing your app in the Google Play Store. Finally, you get different perspectives. So depending on the company or the course's author, you can learn different techniques for tackling the same exact problems. And I wanted to show you just an example here from Udacity. These are 4 courses which I highly recommend to those who want to level up their skills as Android developers. I've taken every single one of these courses, and despite working in the industry for years, I was able to take something away from every single one. So the important thing about learning and study is having that humility to know there's always more that you can learn. You can always pick up one new thing, and a great way to do that is through online courses. The last one I wanted to mention is Caster.io. This website is run by real-world developers out there tackling the challenges. In full disclosure, as one of the instructors, I get to see all of the effort that goes into every single video, and I've also learned a lot from my fellow instructors. So just another great online resource. This quote I felt was especially applicable to our final 2 tools in this section, and that is, if you associate with eagles, you will learn how to soar. And I took this to mean that if we decide to spend time with those who are already like flying high, so to speak, then it can help us to reach new levels as developers. And the best way to do that is by attending conferences, just like where we are today. If you take a second, just look to your left, look to your right. I see you, people up top, look. Okay, you're here. You're here among people who are already really passionate about Android and what Android has to offer. You also get the opportunity to hear from the experts right from the stage. And even later, you can politely stalk them and ask them your personal questions related to the challenges that you're dealing with in your particular application. You also get to grow your network. So say, for example, you're not doing anything in IoT right now, but guess what? People here are, and you can attach yourself to them, and maybe a year from now, you can go and tap into their expertise. So just a perfect example of growing your network. Also, conferences allow you to learn new techniques. Maybe you've always done something using X. Then you go to a conference and they say, here's why. Wow, now you're in love. You have this new favorite way of solving problems, all because you took the time to attend a conference. So just truly invaluable. And this brings me to my final tool in this section, and that's open source. Open source is great because you get these countless examples of ways to deal with things inside of your Android applications. If you have a schedule which allows it, you can try to contribute to open source, which allows you to learn by doing, which is always very nice. And then finally, you can see design patterns in action. One thing I like to do when I include an open source library in my application is I go check out the source code. I want to see what I can learn from these other developers. Maybe they're using the builder pattern in order to configure something. Maybe they have a unique way of structuring their files that I can learn from and adopt in my own application. It's all out there available to us. And another thing about open source, if you're like me, you use GitHub, and I like to star things, like a lot. I'm almost like star crazy, really. If I see a library and I think, one day I might need to inspect Bluetooth traffic, star. That's just how I am. I also tend to follow other developers who I respect in the Android community. So I'll see which things they're starring or maybe new projects that they've started working on. All of this just through GitHub, which I'm using every day anyway. So when it comes to study, we've talked about newsletters, podcasts, online courses, conferences, and open source. What's amazing about our community is that most of the things we mentioned are available for free. We don't have to pay anything, yet we do have to put forth some effort in order to avail ourselves of these various resources. Now this brings us to our second section, and that is prevention. In the medical field, it's common practice to vaccinate children against dangerous illnesses, right? We feel that vaccines will work with the body's natural defenses and hopefully can prevent them from getting ill. We also have several preventative measures that we can take to help prevent bugs from getting in our applications before they affect our end users. And we're going to look at all of these today, just one by one, discuss these different techniques that we can use, starting with static code analysis. So static code analysis works in basically two ways when it comes to Java, either on your source code or your compiled bytecode. Regardless of which option, they share some basic traits, and they pretty much develop a model of your code and then try to help point out issues to you. These are the four that I use the most often: check style, find bugs, lint, and PMD. And I took a survey before I came here of almost 200 Android developers and asked them a few questions about which development tools they used. And here were the answers when it came to static code analysis. So if we come over here, hopefully my clicker will still work. You see that almost everyone is using Android Lint right now for their static analysis needs, but there was also a pretty large percentage of people who rely on check style and find bugs as well to diagnose issues in their applications. And speaking of find bugs, if you're not familiar with it, it develops this model of your code and it tries to help point out common issues to us. And it will then give us this HTML report where it'll say, like, here's the medium issues, things that you probably should fix. Here's the high issues. Please fix these, like, please, pretty, please, maybe, I don't know. And then you can dig into each one of the issues. So we'll give you an explanation. Hey, that field isn't final and someone can do something weird with it. That class should be static. So not only are you finding issues in your application, you're learning because now you know why. Oh, why should that be static? Oh, I didn't know that about Java classes. Great. And so it's really nice. It's like you're having this objective third party kind of looking over your shoulder as you're coding your application. Now, I want you to imagine this. Like, go back to whatever grade that was when we used to imagine things. And you're going in for surgery. You go in the room, and there's just this one scary doctor there. No doubt, your level of anxiety would increase dramatically. Now, picture yourself in that same room, but there's now a team of doctors. Wouldn't you feel more relaxed, more at ease? You know there's someone there making sure the proper procedures are being followed. Someone else is monitoring your health. There's another person making sure the right tools are being used. And that's similar to what we get with code reviews. So there were so many different benefits of having code reviews inside of your application, but I just jotted down a few that really jumped out to me. So the first one is that you can catch issues before they impact production. So typically, if you maybe have a continuous integration environment running, you can execute that against every single pull request. And then you can also have your colleagues there saying, wait a minute, that looks like that'll be null, or that looks like XYZ. You can also gain exposure to new ideas and new techniques. So as you're talking with someone else, they may say, hey, this layout looks like it could benefit from a merge tag. Oh, what's a merge tag? And just like that, you're sharing that knowledge among your team. It also helps to promote consistent design. So you won't have like one person doing crazy things with the code and everyone else is using like a modular abstraction and like this person's not. And you can also ensure maintainability. So there isn't just that one person that knows all the things on the whole team. Everyone can share that knowledge. What's nice about GitHub, I know I don't work for them, I just like it. The code reviews have improved recently where you can pick multiple people to review them to help streamline that feedback. And then they can say, well, look, I'm not going to approve this yet. I'm going to add a few comments. Nice work, but use a merge tag. And you can kind of go from there. So it's like a more conversational flow and more people can be involved, which I really appreciate about it. And then this brings us to our next tool, Leak Canary. I grappled a little bit with including Leak Canary in this section because I consider it not only a preventative measure, but also a diagnostic measure. But let's kind of focus on some of the preventative aspects of it. It helps you to catch memory leaks in your application. The setup is very minimal. You basically add some things to your build.gradle file, little changes to your application class, boom, you've got Leak Canary. So let me try a little experiment here. Let's look at this code. Can anyone just yell it out? What's wrong? There we go. Static reference, static toolbar. Exactly. Come work for me, whoever said that. No, perfect. So if you have Leak Canary installed, what's going to happen? It'll see that code and give you a notification. Like, uh-oh, look, there's a leak in this activity. Then it will help you track down, there we go, static toolbar, just as we mentioned. So obviously that's a trivial example. We could easily spot, the fact that it was the static toolbar, but often it's something much more nefarious that's not easy to find. And so by having Leak Canary installed, we can help prevent these issues before they actually impact our users. Now the next thing we'll talk about is architecture. The way we actually design our code can help prevent issues reaching our users as well. If we look at this example of this class called foo, it's just a giant God class. It has all these different dependencies. It's more difficult to catch bugs in something like this, as well as add new features without worrying about possibly injecting some issues. Instead, we want to opt for more modular design with fewer dependencies kind of spread throughout them, something similar to what we see going on here. In order to achieve this wonderful type of architecture, I like to use the combination of MVP or Model View Presenter coupled with Dagger. And I feel that that does a great job in kind of helping keep things modular and also more maintainable. If you're curious about learning more on how to architect your application, there's a talk coming up, Clean Architecture, where Joe Birch promises to go into even more detail about the different patterns available to you and how you can take advantage of it in your Android applications. The next thing we want to talk about is automated testing. And I found this image on Martin Fowler's website. I think it does a great job of conveying the various costs involved with creating tests. So here you'll see that unit tests are typically fast and cheap, whereas the UI tests tend to be slower and a little more expensive to write. So that means that as developers, we would want to have more and more unit tests over the latter. For this, I like to use JUnit coupled with Mockito, and that does a really good job of getting me there where I need to be as far as my code coverage and making sure I have enough very solid test foundation. Also, I connect up my continuous integration environment. I'm running Jenkins in order to execute those tests every time someone submits a pull request. So just constantly making sure we have things in place in order to keep the code clean and try to minimize bugs. And the final thing we're going to talk about is API testing. So as developers, we often have to integrate with some type of backend service. And when issues happen, it tends to be this kind of finger pointing game. No, we always sent you that field. No, actually, it was never there. Well, my app, I had enough. I was like, that's it. We got to find a solution. Enters Postman. So Postman is a tool that lets you execute REST requests. It has a very nice GUI associated with it, but you can also add testing to it. So I just wanted to spend a few minutes kind of scratching the surface of what Postman has to offer. In order to send your API testing, you just send a request, get a response, run the test. It's really 1, 2, 3 when it comes to Postman, which is pretty cool. So I wanted to show you an example of sending a request. So I'm here inside of the Postman GUI on Mac, and over here I have some sample API endpoints that I want to execute. So I'll just come to my collection. You'll kind of see there it is. It's a GET request. And then in the center, we'll see the URL that I want to have executed. And then there's just a giant blue button that says send, and I click send. And then my response will appear below. That's it. That's all we have to do to execute API requests with Postman. And here's a close-up of the response that I received when I just executed that request. So I have an array of some post objects. If you want to know more, you can use this website, JSON placeholder, to give you just like fake JSON data, which is pretty cool. So I want to write a test. I want to make sure every time I execute that request that it was successful. This is all I have to do. Make sure the status code is 200. So in the Postman GUI, I get a response code and I can just check it. I'm done. Now every single time I run that request, if it ever fails, then Postman will notify me. So just like that, you could add this one test on every single endpoint in your API that you want, and then you will know whether or not the API is passing. Okay, but let's step it up a notch. Let's say I want to make sure that I actually get an array. I can create this JavaScript variable, set a type on it, and say it should be an array or null. I'm fine with either one. Parse the response body as JSON, and then Postman gives me this TV4 validator. I don't have to know what TV4 is all about. I just know I call the validate method. And it would report back to me if for any reason the API didn't send me an array or null. Super useful. But it gets even better. Now, some of you, your jaws are already dropping, so you're not going to believe the next thing that it can do, but get ready. Okay, let's say I want to now make sure that the actual model object is all in the correct format. I can put a properties on every single one. So if you look here, we have the user ID and ID are integers. Title and body are strings. So just imagine your whole entire API response. You can specify the exact fields that you want to get back here in the JavaScript. And then when you run your test, if anything is different from what you expected, then Postman will tell us, oh, look, this is invalid. Here's the path. This is what you told me it should be. This is what it was. So extremely, extremely useful. What's more, you can have the ability to set up monitors for all of your Postman tests. So let's say you have like 10 different API endpoints. You wrote 5 different tests for every single one. You can create a monitor to automatically run all those tests. Here's an example of running a monitor manually. So just have it set up to my collection, push play, it runs all the tests and will report back to me any errors. What's cool about the monitors is you can choose your own schedule. So you can say, run all my tests once a week, run them every single day. And anytime the monitor is executed, you'll get a daily report from Postman. So you'll automatically know what the issues are. I like to run all my tests against staging so that I can try to catch them before they push something out to production. So I'll run all my tests against our staging API. If there's any issues, I'm like, hey, wait a minute, that's a float, it's supposed to be an integer. Who changed it? What's going on? It'll break the app. So it's just really, really useful tool. And once and for all, that whole like finger pointing war has finally been fought and won by means of Postman, which is pretty cool. So we looked at all these different techniques for preventing bugs in our application. And as I mentioned, we were only able to kind of scratch the surface. So I really encourage you to just take some time out and see which one of these things you could incorporate in your applications to kind of help prevent more and more bugs from sneaking in and affecting your end users. Our final section is going to be about diagnosis. So when a person comes to the doctor, they have all these different symptoms. And now the doctor has to do the challenging job of figuring out, well, what is the root cause? What's actually wrong with this person? And normally they'll look at their medical history, they may do a physical exam, they use some different tools, all to try to figure out what the issue is. And when it comes to diagnosing issues in our applications, and so here's an example. Let's say we have a 74-year-old, they say, oh, I have stomach pain, right? A 34-year-old comes in, oh, I have some stomach pain. The doctor's like, you both have the same problem. Probably not, right? So we'll say, okay, let's look at the age, let's look at the history, let me look at these things. Okay, you may have this issue, you may have that issue. That's kind of how diagnosis works. So the patient is actually the key factor in determining the final outcome of the diagnosis. And so when it comes to our code, the key factor in determining the diagnosis is actually you, because you as a developer are the most intimately familiar with the code. You know the scary sections that always have the secret bugs. So you really are the best tool to try to fix issues in your application. However, like any good doctor, you would still take advantage of various tools to help diagnose issues. So at this time, I would like you to just take like 30 seconds, and I want you to try to think of the top 3 tools that you would use to diagnose issues inside of your application. Just kind of right off the top of your head, 3 tools that you use to diagnose issues. And I'll have like a few people kind of circulating to give you like some paper to write it down. So yeah, I'm gonna eventually time you. So by the time you get the paper, you probably have like 50 tools in your head. But just write down 3, okay? So 30 seconds. People up top, your paper should be coming. I didn't forget about you. Okay. If you don't fix bugs, I guess don't write anything. I don't know. I'm just trying to help everyone out here. Okay. I'm assuming you have your three tools like in your head or written, which is great. Now, just take like 1 minute, give your paper to your neighbor, and tell them why you chose the 3 tools you did. Okay, so this is like, meeting people. I know it's weird, but just pass it to your neighbor. Okay? Good. No Q&A.
No Q&A?
Mm. All right. Great. Okay, so hopefully you shared your 3 things with your neighbor. Now, let's have 3 brave folks just read out the 3 things on the paper in front of you. So that's anyone around the stairs. 3. Yes. Okay. Okay. Logcat. Awesome. One more. Right here. Right, yes. Very nice. One more person. Someone up top. Up top. Come on, you're in the VIP seats. One person. Right here? This guy? Okay. Here? Yes. Crashlytics? Awesome. Okay. All right, you. Grafana. Okay, good. I haven't heard of that one. I'll come find you. Thank you. Now, we mentioned a few of the things that we're actually going to talk about today, so it's awesome. Now, the key thing that we use to debug issues in our applications is no doubt Android Studio, our IDE of choice. So we'll definitely be talking about some of the things included in Android Studio that can help us to track down bugs and squash them. Well, we're going to first look at things we can do in our own code. We're going to look at things outside of Android Studio, move inside, and then things we can do in our emulator or on a device. So let's start with our own code. This was actually mentioned. The simplest thing you can do is just write some logs. Like really, it's the simplest thing that we can do. Here's an example. I like to use Timber. It's really nice. It lets me choose which logs make it into release builds or not. And it's a simple way to track things down. Someone else also mentioned PidCat, LogCat. Here's an example. PidCat is just the cousin of LogCat, I'll say. You can see the line number of certain issues, get to the root cause, and fix it. These are typically some of the easiest bugs to find just because we put some logs in our code. But when it comes to our users, what's interesting is we really never know what they're doing with our apps. We put all this work into it and then we kind of give it to them and, we need to find out what's going on when they're outside of the safe confines of our debug environment. In order to do that, we should add some events. So this is a simple way. I'm sending events to my typical analytics tracker, but then I also say, hey, if I have Fabric or Crashlytics around, let me go ahead and send an event to them as well. Well, what does that do for me when I get issues from my end user? I can go into Crashlytics and I basically have like some little breadcrumbs to see what they were doing. So they logged in, it failed, and it crashed. Okay, I have somewhere to start. I'll log in and fail and see if I crash. So at least this way, just by logging those events, it can help speed up the level with which we can kind of track the issues, debug them, fix them. Now, let's move on to outside of Android Studio. We briefly looked at Crashlytics just a little bit, but I want to spend a little more time talking about what it can do for you. One feature I super like about Crashlytics is that it has the stability report between the different versions of my application. So one thing I like to do is use stage rollouts on Google Play, so if you're familiar with that, and I'll just roll it out to a small percentage of the users. And then I monitor this stability report to make sure that my new release didn't cause any regressions or that there isn't a new bug there. So if there's something new, I can quickly fix it before it impacts the whole population, all because I'm here checking this available to me in Crashlytics. Another nice thing is that it can break down the different Android versions as well as the devices that your users are on. So if you have a huge percentage of your users running the Samsung something, unfortunately, you need to fix that Samsung something. You may want to focus your efforts on that in comparison to like your favorite Pixel. So this is just a nice way to see, actually all my users are not on Pixel. Maybe I need to get a Samsung and fix it. So it's a really sweet tool available inside of Crashlytics. The next thing I want to talk about is Classy Shark. And I really like Classy Shark for trying to fix issues that aren't in my code. So sometimes I'll add a third-party dependency and that's causing a crash or that's causing some weird issue. And I can use Classy Shark in order to track it down. It also recently added this APK dashboard, which allows me to go in and see if there's any duplicate dependencies, some third party brought in, some weird native libraries being included. It's just like that one-stop shop for figuring out what's happening with all of my third-party dependencies. And the next tool I want to talk about is Battery Historian. Now, as the name implies, it tells you stuff about batteries, but the battery on your phone, and it's really cool. I just want to show you a close-up view of one example. So here, it detects that the GPS was active for 26 minutes. Like, that's just bad. That wasn't on purpose. That was an accident. And I would have had no idea if I didn't check and someone said the battery's real slow with this app, right? So that's the kind of useful information people give you. Then you have to say, okay, we need data. Battery Historian gives you tons of data. Another cool thing, it gives you the list of apps based on CPU usage. So this is my phone. I got the top 5 apps, and I was like, Fitbit? I barely walk. Anyway, it's using a lot of CPU though. So let's say I'm working on an app and it's in this list. Oh no, it's doing something it's not supposed to do. It shouldn't be in the top 5. And then I can try to take action. If you want to know even more about batteries, there's another talk on being a good battery citizen by Eric that promises to share even more techniques on debugging issues and finding out what's going on with your app and your device's battery. The next tool I'm going to talk about is mitten proxy. So someone over here, I think, mentioned Charles proxy. It's very similar. It stands for man in the middle. And this is just a way to sniff HTTP, HTTPS traffic on your device. This is kind of a simple way. It gets extremely more complicated when we get to the S part of HTTP. But fortunately for us as developers, that's all happening behind the scenes. We just do a little bit of setup like this, add some certificates, and then we can use mitten proxy on our device. I want to show you an example of how it works. So here I am, my app sniffing traffic, and a request was being made to the segment API. So I can see what was sent, headers, information, type. I can even look at the response that segment sent back. Just a perfect way to debug traffic. This has helped me to detect like duplicate image requests that were being made from my app. Also, there was another scenario where there were many more requests happening than I had anticipated, and our app has to work in network constrained areas. So I was able to figure all of that out just by running mitten proxy. And the final tool I want to talk about is systrace. The UI isn't the best, it's not, but you can quickly spot issues. There's also an alerts pane. Like if you don't want to look at that screen, just don't look at it. Just click on alerts. It'll give you a list of everything that's wrong. And then you can go into detail and figure out like what's happening, and possibly here's a video to tell you how to fix it. So really nice tool, systrace. Now let's move inside of Android Studio. Here's the APK analyzer. So hopefully most of us are familiar with that. APKs used to be this big black box. Now we can use APK Analyzer to really dig in and find out more about what's going on. Also coming to you in Android Studio 2.4 is the Android Profiler, which gives us like this very nice information about CPU, network, and memory. Here's an example of me on the memory tab taking a heap dump. This always will sound weird. And then you'll see all the information right there in that one place, which is pretty cool that they've consolidated all of that for us. There's also information now about CPU. I couldn't really get it to work for some reason, but it's still in preview, so hopefully by Google I/O it'll be amazing. Which means there's no more trace view. Sorry, I know, this makes some of you sad. I was sad for a second. This is kind of how it's supposed to look, so when it works, I think it's going to be really awesome. And finally, we're going to look at things inside of our emulator. I want to kind of zoom past these to make sure I end on time. So we have the GPU overdraw, which kind of helps you spot if you're like drawing multiple pixels on top of each other. You want to kind of keep it in the sweet spot of blue and green only 1 or 2 times. If you enable that option on your emulator device, you'll get this kind of cool green, red, blue looking screen. Here's a before shot with lots of overdraw. After one small change, you get more blue. So it's really nice to use. The next one is profile GPU rendering. You want to try to keep things underneath the green line, which is that 16 millisecond frame rate. If things going above it, you have a lot of jank in your app. And I like to use this whenever someone says, like, on this particular device, it takes a long time to load this screen. And I can just enable it and look at the jank and see what's going on. So we looked at over a dozen tools today, all in an effort to help us prevent issues in our apps or diagnose them. And before I leave you, I wanted to share a few words with those from the Android community.
First,
do.
First, do no harm.
Do no
Harm.
First,
Do no harm.
harm. First,
First, do no harm.
Do no harm.
Or else we'll make you walk the plank, matey.
So that was awesome. I had a lot of fun putting that mashup together. Probably not as much fun as they had recording it. However, what's really nice is that sometimes it can feel a little overwhelming, all the things that we need to do in order to be, experts or so advanced in this industry. But I'd like you to just remember these things. First of all, it takes study. So you have to put in some effort. You have to learn. Second, you need to have some preventative techniques available to prevent those bugs from getting in your apps. Third, skillful handling of diagnostic tools in order to debug issues when they arrive. But whatever thing you choose to tackle next, first, do no harm. You didn't see that coming? Come on. All right. Thank you. Thank you.